when it reaches the maximum height. Now, the velocity is 0 meters per second, and the acceleration, Jamie said, was negative 9.81 meters per second squared. But Jamie, the question here, though, is what is the name of the location at the top? It's not the vortex or vertex. That's not it. Yeah, in math class, that's what y'all call it. But in physics class, what do we call that top location? Non-zero acceleration is where we call that top location right there. Now, the final velocity and acceleration of the ball just before it hits the ground. So if it was tossed up with a positive 12, right before it hits the ground, it's a negative 12 meters per second and a negative 9.81 meters per second and square. And because of that negative and negative vector in the same direction is the reason why it increases speed as it falls down. But so far, nobody got letter C correct yet. Eric, what if instead of it hitting the ground where it would be the 12 or the negative 12, there was a hole in the ground? What would the final velocity of this ball be then? Give me something. You got it? Yeah, there you go. Good encouragement. Come on now, Eric. It might be. I agree. It's faster. I agree. It's greater than 12 meters per second. Wait a minute. Greater than negative 12 meters per second. Last class period, somebody says, well, don't you need less than? Well, we go, whoa. I go, remember, you're thinking of a number line, like this is 0, and then negative 1, negative 2, negative 3. I said 1, 2, 3, 4. No. Remember, greater. So it could be negative 15. It could be negative 12.5. I don't know, but it's going to be bigger. Remember, that negative doesn't mean like a negative number line. It just means negative direction. So here at this location, 9.81 negative meters per second square is going to be the A answer for every location. If this one, it would be negative 12 meters per second, and this one is 0 meters per second for velocity. But somebody at the 8 o'clock class had a really good question here. They said, I don't know why this is a 4, Miss Munson, and that's a negative 4. If that is 0 and this is 12, shouldn't that be like a 6? I was like, ooh, good question there. That's because that student was thinking that everything was going to fall evenly. But gravity is an acceleration, which means that it speeds up. For every second an object is falling, it speeds up by negative 9.81 meters. So the first second is going to be 9.81, and then the velocity does what? Increases, because gravity is an acceleration pulling down on it. It's not going to be 0, 6, 12. It won't be like a nice even. It's not going to be 0, 2, 4, 6, 8, 10, 12. Okay? It's going to jump because it exponentially increases. Let's keep going. Jamie, 2 children are bouncing these balls. One of them drops it and then one throws it down. What is the acceleration of gravity on these 2, tennis balls? There you go. The acceleration of gravity is the same, whether you tossed it down or whether you threw it down. And the acceleration of gravity, even if you were to hold it in your hand, it's still negative 9.81 of gravity pulling down on it. And the same thing over here, negative 9.81 meters per second square for all 3 answers on the way up, at the top, and on the way down. Then over here on the next page, remember, my dog did not take a bullet for y'all just to take a bullet. So 8 a.m. class, about half the class, either number 1, they were lazy, or number 2, they just really didn't understand the whole point of us shooting the dog last week, right? Sacrifice the dog for this. If vectors are in the same direction, Jamie, you do what? If vectors are in opposite direction, you do what? I agree. Miss Wells, number 1, 1 and 3, what's my answer? I'm sorry, 1 and 2.
Your answer is 3.
Dang it, Miss Wells. What direction?
Right, there we go. That's
Okay.
which way that is.
1 and 1. Miss,
Zero.
what's my direction?
There is none.
Oh, leave it blank. Good call. They cancel each other out. Nothing. Here you go. Nothing. If you later on, I will say, Oscar, later on, we're going to start doing diagram pictures drawings. I would just draw the picture, kind of like you said, or even just the dot and just done. It's not, it cancels out. Let's keep going, Miss Wells. 2 and 1.
1
What direction?
left.
1 and 3.
2 down.
4 and 1.
3 up.
I agree. Somebody said earlier today, isn't that negative 2? Do I have to? Well, doesn't the direction tells you that it's negative? So no need for that negative anymore because we know it now. Now that we're utilizing vectors, we don't need to draw that negative because the negative is the vector direction. Then we came over here and we talked about Pythagorean last week, which was a quick reminder. We needed this because some of us forgot that this right angle, if you draw an arrow from it, that is always going to be your hypotenuse leg, which is going to always be the biggest leg, okay? So all of them were a squared plus b squared equals c squared. And so when you did that, this was 6 squared plus 3 squared equals c squared. Remember, hypotenuse leg must be the largest leg, so your answer should have been 6.71. But wait, if they are the same units, then that's the same unit. If one is 1 and one is a different one, then you're going to have to convert them to make them the same unit. So both of them are centimeters, so 6.71 centimeters. Next one, 12 squared plus 5 squared. My hypotenuse better be bigger, 13 centimeters. And then the last one, 2 squared plus 5 squared. My hypotenuse better be bigger, which comes out to 5.39 meters. No need to round. You just leave it there. 5.39. Yes, ma'am. Yes, ma'am. But just go there and come straight back because sometimes you always come back with a story.
My stories happen there, though. Like, I don't know what you want me to tell you.
Somehow you always seem to be in the middle of the situation.
It's not my fault.
Okay. Now, on number 9, somebody at 8 a.m. class kind of disagreed, and it took me a moment for them to understand what number 9 was saying. It says that there's a ladder that's leaning up against the side of a house. So let's do this drawing. Hopefully you drew some kind of drawing. Here's my house. There's a ladder leaning against the side of it. I don't know. Maybe they're going to go and put up the Christmas lights or something. Does it matter, Miss Jamie, if I drew the ladder on this side? Nope. It's the same triangle whether it's this way or this way. Same triangle. Okay, so it does not matter the orientation of it. So let's go ahead. It says here that the house has a distance of 10 meters high. The ladder is 3 meters away from the house, the bottom of that ladder. How tall, question mark, is the ladder? So when I did this drawing, I'm able to see that I have a right angle. So across from the right angle is my hypotenuse, a squared plus b squared equals c squared. 10 squared plus 3 squared equals c squared, or 10.44 meters. And most of the time, you're not going to have a whole number. They're pretty much all going to be decimals. It's okay. It's okay. Then the last one. Remember, today we're going to go a little bit and have triangles, and then after that, I'm going to take the triangles away. Okay? Then after that, later on this week and next week, we're going to talk about two-dimensional we're going to go back to kinematics. But right now, they gave us a triangle. The only thing they asked was please go ahead and label the O, the A, and the H. Remember, if you pointed on the opposite side of the right angle, that guarantees you a hypotenuse. That will always be the hypotenuse leg. The H and that's my H. Now, for those triangles, they gave you this little curve here, and that's considered to be our theta. In a moment, I'm not going to give you a triangle. You're not going to get a theta. You've got to figure that out. But since they gave it to us, that side is always your adjacent. And then left over is your opposite leg. So hopefully that's what your drawings look like. And then the last one over here was, remember we talked about that and we all were kind of, not all of us, but we were kind of wrong. We needed to make sure that on our calculator that we put this in the correct mode. And if you're dealing with a degree, you might want to right now in a moment double check to make sure your calculator, go to mode, which is right here, go to that and make sure it's in degrees. Your sine of 25 degrees actually should have been 0.42, 0.60, and 0.675. Can I give you a hint? If you do this and you get a negative answer, it's guaranteed it's wrong. Go check your mode, okay? Shouldn't be a negative answer. Hint.
How many numbers do you want us after the decimal? Like you
Two.
give us two?
Hopefully 2.
You want the third one?
Nah, I don't, nah. 2 is good. 2 is good. Oh, no. Well, yeah, this is for Ashlyn. It's got good.
Okay, she's getting the story. Whatever.
Sorry, Ashlyn. Okay,
Okay.
you got manners.
Exactly. Like.
I appreciate you not allowing things to just fly like that, like
That is
unacceptable.
so nasty.
I don't know where these people have been raised. Let's don't guess. Let's don't assume which town they're from. Okay? We don't want to say that out loud. That might hurt somebody's feelings.
Boop.
I think they went to Vegas.
What did you say?
Nothing. He didn't say anything.
Miss Billy won't have us out here like that.
Oh. She ain't there no more. It's getting a
You know
little.
they went to Texas.
She'll be dead rolling in her grave.
Whoa. She's very alive, everybody. She's very alive. Some
But I'm
people
saying
make
she'll be
consider
long
that a threat.
gone before she let the niggas
Remember,
do it.
videoing you.
Okay.
Okay.
I'll send
Okay.
that to Miss Billy.
Oh, man. Whew. I love you, Dr. Smith. Here we go. All right, real
Never been
quick.
snatched up by Dr. Smith.
She could be walking down the hall. You're going to hear the click, click, click of her little shoes. Here we go. Unless you're DHS, you won't get it then. Sorry. Okay, real quick. As a quick review, I know some of us are walking away with PTSD. We're videoing this for Miss Ashlyn. She's not going to post this anywhere, so it's just only for her.
Are we filling this out or are we splitting this thing?
Oh, we're gonna come back to it, but it's going to be later. I'm sorry. But she said video for her, so we love you, Ashlyn. As a quick reminder, the whole moral of the story last week was that when vectors are in opposite direction, we subtract them, and that's the reason why this is 0, it decreased. The moral of the story is when vectors are in the same direction, it increases, and that's why it got faster. The negative value doesn't mean it became less, it became more. The value became more. Then we came over here. I know we skipped a little bit of that. Don't forget, vectors in same direction versus vectors in opposite directions. Then we came over here and we talked about this pyramid. And when we drew out this triangle, what did we see? A right angle. And from that right angle, if we have 2 legs, you can use Pythagorean theorem, which is nice and easy. Something that you've done before. But the problem is some of us may have forgotten, but now we remembered, how do I label the A, the O, and the H, which is what this was. Then we need to come over here and remember, if you get a negative number, guarantee you it's wrong. Go back and double check your calculator that you're in degree mode, because this is 25 degrees, all right? Then we get over here to our next topic, and once we finish this next topic, we get done with the, whatever it was, hummingbird, then we can be done for the day. But I want to make sure that we understand this. Yes, ma'am?
No.
I want to,
No.
but I have the last So
You
if
can
you
just
would
give it
like
to
to,
us.
So no.
if you would like to see what it is at this point and then see it again later on Thursday, or would you like to wait for it all on Thursday?
I'd like to live blissfully unaware.
Okay. That, I'm literally down to the last page. That's it. It's that one graph right there, and then those were, like, those bonus points on the back end. That's
Say you
it.
just give it to
I
us.
don't even know if I
Just
can
don't
do
check
this.
them at the point.
No, you're just recording it now. She's gonna snitch to everybody else on it, cause can't do that now. So, can't do that now.
She's probably gonna get 100.
Oh, golly. Remember, we're recording. We can't blast her business and everybody else's business. All right, here we go. So let's get to this part here. The problem is we're not always given two legs of a triangle. Sometimes we're actually given one leg in a theta. Okay? And in that case, we've got a SOHCAHTOA. For those of us who don't remember, maybe you remember the word SOHCAHTOA, but I'm not sure if you remember the full equation. The full equation is if I'm going to use the SO stands for the sine of the theta equals the opposite over the hypotenuse. Okay, one more time. The sine of the theta equals the opposite over the hypotenuse. That's what SO stands for. So the CA stands for the cosine of the theta equals the adjacent over the hypotenuse. And the TOA stands for, I'm sorry, scroll up. Oh, hypot.
Or is there an O?
There is an O. Pot and noose. Yes. Oh, I forgot the O here too. Pot to noose. And the tan of the theta equals the opposite over the adjacent. Okay? Look at the thing over here. If there was something that I'm going to brain dump, I would brain dump that. SOHCAHTOA. Because that's actually your three equations. This tells me that the sine equals the opposite over the adjacent. It tells me that the cosine equals the adjacent over the hypotenuse. And the TOA tells me that the tan of the theta equals the opposite over the adjacent. There goes my equations right there on the SOHCAHTOA part. Okay? You're not given those. You're not given it. So that's, I guess, a memorization. SOHCAHTOA would be your memorization. You're not given it. Now, I'm going to say this next part right here because it's going to come and play later on the next page. And then you're going to need to know this. Okay? So this is a physics thing. So here in physics, if I need to know the direction that my object is traveling, okay, one more time. In physics, the direction my object is traveling is the theta. Okay? Let me spell that out for you. I don't have any notes there. You might want to add notes. This symbol stands for a theta. The direction that my object is going is the theta. And so when we get to that question in a moment, you're going to see it and be like, oh, that's what I got to do. Okay? The direction that my object is going is the theta. Okay? In physics. You know, we don't necessarily, don't get me wrong, negative, positive, I'm going to the right, going to the left. But if I want to know exactly what direction I'm going to go, I'm going to use my theta. I'm going to go 32 degrees. That's my theta. Okay? So let's go ahead and we're going to baby step the SOHCAHTOA. We're not going to full on yet. So here we go. Baby steps of the SOHCAHTOA. I'm not going to give you a triangle later on. I'm not going to give you the theta. I'll give you the number, But you need to figure out where the theta is in just a moment. But this is baby steps. When I baby step it, I always do this equations in a certain way. Step number 1, I label my A, my H, and my O. My A, my H, and my O, right? From an opposite direction or opposite leg from the right angle is my hypotenuse. If I know my theta and my right angle, that's always my adjacent. And what's left over is my opposite. Okay? Step 1. Step 2, I highlight. I highlight what I have and what I'm looking for. I have this number, and I'm looking for this leg, that number. Okay? I highlight what I have and what I'm looking for. And so I have the H, and I'm looking for the O. So which equation, the SO, the CA, or the TOA, utilizes the H and the O? The SO, the S. I agree. The sine of the theta equals the O over the H. The sine of the theta is the O over the H. This is the way I do my math problems when it comes to SOHCAHTOA. I label the legs, I highlight what I have and what I'm looking for. So that way I can figure out, okay, H and O. Now I'm gonna pause for a moment. This equation is set up to look for the sine of the theta. Am I looking for the theta? Jamie, am I looking for the theta? No, they gave it to you. I'm actually looking for, what am I looking for, Jamie? B, which is the opposite leg. So since I'm looking for the opposite leg, or B, well then in this case, I'm gonna have to rearrange this and do some algebra. The cool thing though, is that this can be put into the triangle. That's why I love it. If I cover up the equal, the opposite leg is on top of the division, so it has to go at the top. The H has to go at the bottom, and what's left over? Yep, the sine of the theta. Jamie, you just told me, what am I looking for? The O, the H, or the sine? The opposite. So I'm going to cover that up. I'm going to X this out. The opposite leg equals the hypotenuse leg times the sine of the theta. Bam. I did my algebra by using the triangle. So now I'm algebraically set up for success. I'm ready to go. Fill in the blanks. O equals the hypotenuse, which is 16, multiply it by the sine of 35 degrees. O comes out to, I don't know, I don't have it. Say it again. 9.18. This leg, the hypotenuse is in centimeters, so my answer is in centimeters. Not bad. Trig is easy. The trig is easy. We got this. We should have did awesome in math class already.
You just put that in the calculator?
Uh-huh.
16 and the 6, exactly with the parentheses.
I would put the parentheses. Where's your calculator?
Right here.
I would try it. Try it. Because in a minute, if you don't try it, then you're really going to get confused later on the next page or at the bottom. Okay, so try it. Make sure that you get 9.18. Make sure that you're also in degrees mode. Okay? So 16 parentheses multiplied by the parentheses sine of 35 equals, and how would do that? And you get 9.18. Double check yourselves, please.
Got 9.17.
There you go. That works for me. 9.17. What if you just wrote 9.2? I'm good. 9.2 works. Okay. So let's do this again. I'm going to go to letter D. Okay, letter D. Step number 1. Label the sides of your triangle. If this is my right angle, draw an arrow. This is my hypotenuse. If this is my theta and my right angle, this leg is going to be my adjacent. My leftover is my opposite. Grab my highlighter. I'm going to highlight what I have and what I'm looking for. I have this leg, and I'm looking for this leg. That's the A and the H. The A and the H. So, the ka, or the toa. The so, the ka, or the toa. Eric, which one is it? The ka. The cosine of the theta equals the adjacent over the hypotenuse. I agree. Eric, am I looking for the cosine of the theta? Am I looking for this degrees? No, they gave it to me already. So that means step one, either I need to algebraically do this or put it in the triangle. Because Eric, what am I looking for? P, which is my hypotenuse leg. I'm looking for the H. So I'm going to come over here. This triangle, believe it or not, it can use in most physics. Cover it up. It tells me that the A is on top of the division. The H is at the bottom. The cosine of the theta goes at the bottom. Eric just told me that I'm looking for letter P, which is my hypotenuse. Let's cover up that H. X this. The hypotenuse equals the adjacent over the cosine of the theta. There goes my algebra setup done for me. Now I'm ready for success. Plug in your numbers. 10 over the cosine of the theta, which is 48 degrees. So, Miss Wells, what'd you get? And I'm looking for my hypotenuse, so it better be bigger than 10. She's thinking. And for those of y'all that don't know, we didn't go get our nails done together, but we both got similar nails.
So 14.9.
We got this bond. 14.9. With units? I agree. I agree, 100%. Easy cheesy? Now let's do this for real life in physics, because that was the baby steps for us to get into our physics version. Okay? That was baby steps. I don't give you triangles. I don't give you where everything is. I give you words. Or that's what we get in physics. We get words. All right, so here we go. Big kid stuff now. Going through this one. An archaeologist climbs to the top of the Pyramid of Giza. Now, if the pyramid's height is 140 meters and the width of it is 230 meters, what is the magnitude and the direction of the archaeologist's displacement while climbing from the bottom of the pyramid to the top of the pyramid? That is physics version. Okay? Now, let's look at this. Aiden's like, first thing is, I want to go back real quick. Remember, like, really early in the beginning, like September, I mentioned, biology class, everything's broken into biotic and abiotic. And in physics class, things are broken into two categories, vectors and scalars. And a vector has magnitude and direction. And what did I say on the previous page? I said it was going to come back and get you in a minute. In physics, the direction of an object's movement is the theta. So that means that I'm looking for two answers. You give me one, it's not right. I need two. I need the theta for the direction, and I need the magnitude, which is the distance that it's traveling. So this is words. I need to simplify it for my brain. Let's draw it out. There's a pyramid here. And from this pyramid, it has a height from here to here of 140. It has a width from here to here of 230 meters. And the archaeologist is about to climb it, and the archaeologist is going to climb. Isn't the word displacement a vector quantity, which has magnitude and direction? And if this archaeologist is going to go to the top of the pyramid, where is the magnitude? The dotted line is the magnitude. Where's the direction? This is the theta. Because if my object in physics, whatever direction that my object is traveling, my object's here, and it's traveling in this direction, that is my theta. Does that make sense a little bit? I think we've got to practice it. So we'll practice on the next question too. One more time. Okay? I have to draw a picture, me personally. When I draw the picture, I can identify that my object, the direction that it's traveling, is always going to be the theta. I'm looking for the theta and the magnitude. I'm looking for this distance and this theta. I don't know it. I'm looking for it. Okay? So what I do have is I have this leg and I have this leg. I also see that it produces a right angle, and so if I label my triangle hypotenuse, theta, and right angle, adjacent, leftover is my opposite. Do you see the importance of those steps that we did last week? They're coming now into play. Now, I need to come up with that leg and that theta. So if I have two legs and I'm looking for the other leg, what's that easy equation? Pythagorean. So let's do that. Let's start off easy with a squared plus b squared equals c squared. This is why I do step by step in my class. I want to make sure that we're going to put all the steps together to come up with the final answer. So in that case, what is this? 140 squared plus 230 squared? 115 squared. 115 equals c squared, or 19,600 plus 13,225 equals c squared. Double check my math, because I kind of, okay. 32,825 equals c squared. The opposite of square is square root. C, or my hypotenuse, whatever you want to call it, better be bigger than 140 or 115. I got 181.18. Wait a minute. Both of those are meters, so my unit is a meter. That's only one part of the answer. You're missing the whole other part. You're missing the whole other part. So now I'm going to come over here and I'm going to write 181.18 meters. Okay, now I got all three legs. I have the A, the O, and the H. Now I've got to get this theta. Can I Pythagorean to get a theta? No, I have to SOHCAHTOA if I want a theta. Now, do I want a SO, do I want a CA, or do I want a TOA? Jamie, which two legs do you want to use? Pick which ones. O and A. She wants to, and I'm going to highlight it, just like I did up here. I'm going to highlight it. O and A. Okay. Miss Jamie, you chose the O and the A. Is that a SO, a CA, or a TOA? A TOA. It is a TOA. The tan of the theta equals the opposite over the adjacent. Am I looking for the tan of the theta? Am I looking for the theta? Sure am. So I don't need to rearrange this. I'm looking for the theta. my equation is set up for success. We're good to go. Get your calculator because you better plug this in. This is where I'm telling you, you need to practice. For those of you who don't practice, I'm not going to have any sympathy in my heart for you. Okay, so let's fill this in. The tan of the theta equals the O of 140 over 115. So the tan of the theta, what's 140 divided by 115? 1 point something? $1.2? What's the unit for degrees? Degree. Degree. That little degree is the SI unit. Now I'm going to pause right there because I need to make a point to everybody. Okay? I'm going to pause to make a point. Now, for those of us, you've had some math class before, you talked about circles, right? And let's say this is, I start here, and my arm goes all the way over here. This is a half a circle. How many degrees are in a half a circle? 180. How about this much of a circle? A half of a half? 90. How about a half of a 90? 45. How about a half of a 45? 22.5? 22.25, 22. Okay, how about half of the 22 point something? 11 point something. Look how little 11 point something is. Wait a minute. We just got an answer of 1.2 degrees. Okay, so for those of us who don't know 1.2 degrees, 0 degrees is me walking on this flat surface. Okay? Me walking right here on this flat surface is 0 degrees. I have no theta. There is no angle. You just told me that this was 90. This is 45. This is 22 point something. Half of this is 11 point something. 1.2, that's almost walking like flat ground. Walking on flat ground, is that going to get you to the top of the pyramid? No. Better be a bigger number than that. Did you push something wrong? Did you push 140 into divided by 115 incorrectly? Probably not. You probably pushed it incorrect, and you got 1.2 degrees. I'm trying to make a point. Nope, you're still in the degree mode. You're still in degree mode. So you leave your calculator still in degrees. But what did we do over here when we had a square? We did the opposite, yeah, which is square root. What's the opposite of the theta? The inverse of the theta. Ah, I'm not sure if we did that in math class ever before, or if you ever had to or not. You probably did. So go to your calculator right now, because for those of us, you need to practice. Go hit second key tan, because right above the tan is going to be the -1, which is the opposite of tan, is the inverse of tan. The opposite. Second key tan, 1.2 equals a theta of 50.6 degrees or something like that? 50.19? Okay. 19 degrees. 50.2 degrees, if you rounded it that way. Oh, that looks a lot better. That's a lot better than 1.2 degrees. So when you're looking for the theta, you have to do the inverse, which is the opposite of the theta. Okay, whether it's the inverse of cosine, sine, or tan. Oh, this is what we needed to get to. So far what we've done was just baby steps to get to here. I could have started right here, but I don't think that would have been good for us. I like to step up before we get to here. So now let's practice this again, and I'll leave you alone. And you told me you want to wait till Thursday till I finish grading the last page, and we can do that. Okay? So remember what I said. I said at the hummingbird, I'll leave you alone. I know today is like a lot of math going in here. Okay? All right, so let's read this. This is what we get for physics. We get words. It says here that a hummingbird flies 1.2 meters along a straight path in the sky. Now, upon spotting a flower, the hummingbird goes directly downward at a 90-degree angle down 1.4 meters to hover in front of a flower. What is the hummingbird's displacement? In parentheses, because this is notes, I wrote this includes the angle and magnitude. Because isn't displacement a vector quantity? And vectors are magnitude and a direction. Magnitude, but on quiz and test day, I will not add the parentheses. I'm just going to tell you what's the displacement. And displacement is a vector quantity which has magnitude and direction, which means two answers. You want to get it right? You better give me both answers correct. So let's go ahead. Again, what did I tell you? I like to do a drawing. There's a lot in my head. Let me simplify it. So, hummingbird. Hummingbird. It's pretty good, huh?
Pretty good.
That's pretty good. That's my hummingbird. Okay, so my hummingbird is going to fly along a straight path in the sky of 1.2 meters. Do you agree with this drawing so far? You may not agree with the hummingbird, but 1.2 meters in the sky. All of a sudden, the hummingbird does what? Goes directly downward to a distance of 1.4 meters in front of a flower. Flying, zzz, whatever a hummingbird does, goes straight down. Sorry. Now wait a minute. Here's what I need us to see. Because you know this word already. We talked about it. Remember that week that I was out and absent? You did a whole lab that I need to grade over distance and displacement. And when you had to use the ruler to find the displacement, you found a straight line from the beginning to the end. If this is where the hummingbird originally started, and he needs to displace to the flower, the displacement would be that. And in physics, the direction of the movement of my object is the, what's that T word? Theta. Look, the direction of the movement of my object, the tail end of my object, of my arrow, this is the tail of my arrow, that's my theta. In physics, the tail end of your arrow or of your displacement arrow is your theta. So this is my theta right here. I'm looking for this and I'm looking for that. That's it. Easy cheesy. Well, I've got two legs. I'm looking for the other leg. I see a right angle. So I'm going to go ahead and step number one, right angle, hypotenuse, theta, right angle, adjacent, leftover is my opposite. I'm looking for the c square. So I'm going to come over here and a square plus b square equals c square. 1.2 square plus 1.4 square equals c square. Help me out. 1.2 is 1.44 plus 1.96. 3.4 equals c squared. Sorry, square root it. C equals 1.84. Wait a minute. What goes behind that 4? Meters. That is not my full answer. That's only part of my answer. I need to find the theta, which is the direction. And so for me to find the theta, I'm gonna have to SOHCAHTOA, no ifs, ands, or buts about it. So part 2 is SOHCAHTOA. SOHCAHTOA. I'm gonna come over here now, I'm gonna highlight, and I actually got all 3 legs. This one is 1.84 or 1.8. Jamie, which 2 legs do you want me to highlight? Okay. A and the H. So the A and the H, I come over here, A and H, that's the cosine. So the cosine of the theta equals A over H. I stop and ask myself, is my equation set up for success? It absolutely is. So I'm going to just plug it in. The cosine of the theta equals A of 1.2 over 1.8 or 1.84. I'm definitely going to need your help because last period we did the tan. So I don't have the cosine. So 1.2 divided by 1.84. Miss Jamie, what's that number?
0.65.
Okay. That's not going to work because 0.65 is such a small, that's almost flat surface. So we need to come over here, and when we're looking for a theta, we need to do the inverse of the theta. Plug that in, Eric, into your calculator. Second key cosine of 0.65 comes out to, what is that?
If you do any of them, they would equal the same number. Like if you do any of the close SOHCAHTOA.
I did tan. Last class period, they chose to do tan. 49.48 degrees. Pretty good, huh? Would y'all get 49.4 what? 5? And they got 49.48. Wouldn't that still round up to 49.5 on both numbers? Psh, degrees. It doesn't matter which of you use tan, cosine, or sine. They all come up with the same answer. Pretty awesome. Have a super great day. We're getting out like 15 minutes, 18 minutes early. Have a great day. Let's pause this.